Okay, hello everyone. We are here for a design review, incremental language development for Wolfram language. We have a variety of topics here. Are we really ready for this topic? Should we take something simpler first?
Yeah, we can look at either of the other two options as
Let's look at FileSystemTree first. Oh, that's interesting. So it's actually turning it into a tree.
Yeah, so this is sort of the intersection of the structure that FileSystemMap gives and our trees. There's a futurized ref page that has some examples, but there are some design discussions that Ian and I have been having on and off that we need to kind of sort out exactly what we want to do with them.
Okay. All right. So basically the idea is this runnable or not?
It's not yet in the prototype builds.
Okay. Okay. All right. So for goodness sake, please don't give a Mathematica example. Let's do a Wolfram 1 example, please.
Yep, we can do
Okay.
that.
Okay. By the way, why are the dot files? Do we have an option in file system map and so on to not include hidden files?
I see it's right there. There's an option, hidden files in the details.
I think it should be called include hidden files, true or false. Hidden files just seems,
hidden files like, true. It's unclear if they're hidden or if they're shown.
Right. Can we do that? Like include directories, include hidden files. Who's here representing file system scan? File system.
That'd be me. So
okay.
Yeah, we can do that. We have a file name forms option that is what exists in file system map, but we could have a
fine. But why don't we do include hidden files?
Okay.
And I would suspect that should be false by default.
Yeah, I mean the question there is how we want to generalize that out to other functions that return files. I don't think file names currently has.
I think that would be a good thing to have. Yes, it would be a good thing to do. But I think this is a more extreme case because I don't know. I mean, this case just seems like, I think include hidden files should be an option to all of these file directory scanning things.
Okay. Yeah.
By the way, I mean, how would it, presumably right now it includes them. So I think it would probably be a bad idea to make it default to false.
Yeah, you might be right.
By the way, is that fake output, or do you just have a very bizarre layout? Because right, there's no system files, there's no documentation.
The default.
This isn't built. Like I built this and then ran all this code.
I think those are the files, not the directories.
Yeah, it's a single level deep.
Oh.
So it doesn't show a directory as a leaf here, which I think is probably wrong. Like include directories, I see false.
Well, otherwise there's always this ambiguity. Yeah, there's like an ambiguity. I think it's good that you can know if it's a leaf, then there's a file there.
Fair enough, but what does include directories to true mean?
So the analog that exists in file system map is that we have an include directories option in file system map because there are some functions you may want to apply to directories and as well as files.
So what did you have in mind for file system tree? Why not the same thing? I mean, that is whether to include in the tree directories, well, as leaves. I mean, elsewhere, how could you not include them in the tree?
Can you open this section in the agenda?
I have to say also that I find it very weird that FileSystemTree apparently defaults to level 1 instead of infinity. Like the Windows tree function, right? Gives you the full tree hierarchy. It's basically find the dot for those of you who are versed in Unix command line.
Well, the only problem is that find dot gives you sequential output, right? It doesn't just.
Sure, but morally it's it's traversing the whole tree, whereas this is basically giving you ls.
Yeah, I understand.
Right. I mean, a file system map, I think it makes sense for it to be level 1, if nothing else, because map is generally level 1. but I agree. I mean, for tree, it seems like it's more important for it to return the whole tree than for it to be consistent with file system map.
I agree. But
Yeah,
the only problem is that it could go very, very deep.
Well,
I mean,
if you have a lot of files, then, such as then the tree will be very big. Yes.
But I mean, file names, comma infinity would also be very big.
Yep.
Okay, let's take it from the top. Where should we start looking at this design? So the root has no data. Why the heck does the root have no data? What?
That's what. So currently, I'm saying file system tree uses the directory you give as the data, which is different from file system map, which just returns an association.
Okay, hold on. File system map on a top level directory just gives the first level, doesn't say the name of the top level directory, it just gives the files in the top level directory, correct?
Correct.
Okay. So the difference here is that there's an anchor that is the name of the directory, which you wouldn't give in file system map, because like map wouldn't give the head of the function. Well, that doesn't make any sense.
Well, I think it's just that map is returning, file system map returns like an association.
Yes.
As opposed to this, which returns a tree. The equivalent thing for this would be if it returned a forest, but we don't support those.
Right.
What does forest mean in this context?
Collection of trees.
I see.
Question, is there a forest? I was going to say, is there a forestry plan? Never mind. Is there
I think lists of trees suffice.
Okay.
But then if this did, I agree. And I think that if this returned a list of trees, that would be goofy.
Yes, I agree. Therefore, I think the right answer is it probably does want to go from the root that includes, okay, so let me just understand what the structure is here. So in this tree, the data, the payload, is always the name of the file or directory at that position in the tree.
With the exception of the root.
Yeah.
Why is that with the exception of the root? That's a directory.
The root is not the file name, it's the file path.
It's basically the input.
It's absolute file name of file name.
Well, it's just, if you gave a relative path, there'd be a relative path there.
Right. The alternative is that example, the alternative to, which I think is funky. Right. I mean, that way every node, is an actual directory or leaf, but
okay, so
that's
hold on.
so weird.
Okay, let's see the absolute path.
Or you could convert everything to an absolute path for the root.
So by the way, actually, just in the tree objects, like, is the data, I don't know the terminology here, is the data, like the payload of the tree object, is it just a string, or is it
any expression?
What was that?
In a general tree, it's any expression.
Oh yeah, but I mean in this one here, I mean for the file names,
yes,
is it just a string or something, or okay. Well, I guess
potentially the symbol all, but we'll get to that.
Okay, sure.
Okay,
but I guess the question is though, I'm just wondering if maybe it would be useful to either put some other stuff in there or make it possible to get other stuff, because I mean I can imagine things where as you're going through the tree, you want the full file path, not just the file name. In order to get that, you'd have to sort of be keeping track of where you are. Like, but maybe
we have exactly that option in file systems map. We have exactly that option, whether to give the full file name, right, in the association. Correct, guys? Oh, for God's sake, let's not use a Windows machine here for this. Why are we doing this? Why are we doing this? Please let's not do that. It's just really confusing. Okay? Can somebody fix that, please?
Yeah, I will take care of that.
It should not have happened that way. Okay? Okay, but in any case, we've got this different... I don't even
Yeah,
know
yeah,
what the hell
it's-
this is doing. I mean, isn't there a way? Isn't there an option to give the full file names?
I think what it is that the full file path is used for the leaves in file system map. You apply the function to the full file path, but the inner nodes are just file names.
No, that's not
Correct.
correct. In this stupid case, with the stupid backslashes, which make it super hard to understand, really hard to understand. And there's a very anemic collection of examples here that really should be improved. Okay, in any case, there is an option here, is there not?
There's a fourth argument that specifies the level of flattening effectively. So we
Down
can
to level
say-
n.
Yep.
Okay. Gives a nested association with R levels. So if that R levels is 1,
Then we get the file path. Yeah.
then you get the file path as the specification here.
Right. That's the key
Right.
for the association.
Really annoys me that these are really dumb file names. Please use something that doesn't have underscores or other stupid confusions in it. Fair?
Yeah, I think the original rationale for this was to use things that were in the installation directory because they would be consistent. But yeah, they're not good.
Yeah, and how about you don't use the Mathematica one, please?
Right. Mhm.
And can you make sure that other examples are checked for the same thing?
Yep, I will run through our file examples.
Okay.
So by the way, is there a tree function that's sort of like TreeMap, but where it tells you at each step what the path to the root is?
I think that would essentially be TreeMap indexed.
Well, kind of, but
have.
I'm thinking of something like, I'm thinking of, yeah, I was thinking more of something where you get the content of all the nodes back up, not just the path, right? Because that would be sort of the case of like, as you're mapping over, like the question in this case is, could you map over the tree and then be given the path all the way back up and then just call file name join on that path? And then it's like equivalent to mapping over the, you know, with the file paths, the full file paths in the content.
We don't have that operation, but I know what you're referring to.
Okay, so you're saying
Starting
take
at,
the payload
starting at the root and going down each like branch, and
with the
track.
payload at each branch.
Yeah, I mean, I'm wondering, it might be, I'm looking at the documentation for TreeMap as well. Like if you go into the details, I mean, it has these different LMs, but I'm not sure if it's easy to get that from one of these LMs, but yeah.
Not currently. It would need to be extended.
This here. Okay, so that's an interesting suggestion in its own right. But let's come back to file system tree. Okay, so again, the objective here, and this will be more and more interesting as we have elided trees, which hopefully we're going to get. Am I making sense? Do you understand what I mean?
Yeah, we're planning a function tree top that just gives the top in levels.
Yeah, I understand. I mean, there's a question here of a lazy elided tree. That is, you go down a certain number of levels, and when you press a button, so to speak, it will open more stuff and go.
So John
Yeah.
has a proposal about that in for the tree outline meeting, which I guess there was some reason why it couldn't be scheduled last week, but that was already on the agenda.
Okay, and how does that relate to this? The file system.
So, well, I mean, that is John's proposal is sort of a more general version. I guess the way to right, it's not just for file systems, it's right any sort of
I understand, but I'm asking, how does that relate to the design we're trying to do today here?
Right. So I guess the right, this is the non-late, this is the eager version. It goes and sucks everything in.
Okay, but the question is the other one an overlay that can be added to any tree-like structure? Do you understand what I'm asking? Or are we going to redo the design twice for this? Do you understand my question?
Well, it can be used to generate trees from any sort of generator function.
That's not answering my question.
All right.
I mean, the point that I'm making is we shouldn't be doing this design if in fact we are going to be primarily interested in the dynamic version of this when we don't know how the dynamic tree stuff is going to work. I'm making sense? All right, let's do one more pass of this, but then I suspect okay. So the first issue is how to handle the root. I'm not a big fan of having this thing that has a very different structure at the root. I don't quite understand why we're not giving just the directory name of the root. Understand? Why are we
that would
giving
be
the full
alternative 2.
Well, but without
Right.
this proboscis here.
Well, where do you want to start? You want to start at Mathematica?
Or at layout.
I wanted to start at the place where you said, okay, so somewhere.
That's what this is.
You said /Mathematica/layout. Where did you start?
Right, that dollar installation directory is an absolute.
What was the
file.
input? What was the input?
/Mathematica/layout.
Okay, then it should probably be this one.
Well, no. But hold on. 2 points about why that's a bad idea. I think so. First is that this directory that you happen to give it is very close to the root of your file system. If you give it something in I don't know, it's in documents /Mathematica project / whatever, it's going to be like 7 layers deep, and you're going to have 7 things in the tree. And also, if you want to say TreeMap over this, or I don't know, if you want to, like, if you're actually doing operations on this tree, you need to know basically, okay, how many levels of junk do I have to go down before I get to the real content? And also the level spec that you give this about how deep to go is going to be relative to the real content point, not the actual depth of the tree.
Yeah, I agree with that. I mean, right. Right. The point, I mean, I think part of the issue here is that he used an absolute file name, right? Presumably, if you did file system tree of ... then you would see ... in that node, which admittedly is different, but it's easily relatable to the input that was given.
I'm not sure why that makes sense. I mean, I'm beginning to think that this alternative is actually the better alternative, like file system map. I mean, maybe we have a way of getting the whole thing, but maybe that's where you start.
Right. Well, yeah, but then you have no way of knowing where this tree is rooted.
That's correct. Because you asked for this tree, and what you got was the tree. So think about the following thing. People have a piece of code that's running on different people's computers where where the full root file, the full routing of that file system tree is completely different on different people's computers. And they don't really want to see all that stuff. They just want to see from the place where I cared on down. Somebody has installed some big structure. They want to see the thing from the installation point on down. Am I making sense?
Well, right, except if you compare with, say, what find does, right? Find uses whatever you give it, right? So find dot will give you dots.
I know, but this isn't the same thing as find, and it has different use cases. I mean, find is showing you.
Find allows you to manipulate the things, right? You can execute commands on the things you get.
All right, but what do we think file system tree is going to be used for? Other than to admire the tree. And for example, being able to get the file system tree without all the stupid names of things would be very useful. Just the structure of the tree. Am I making sense? And hopefully we're going to have some easy functions to do that, right?
And you could probably just do TreeMap of null ampersand.
No, right? No, I understand, but I'm just checking with Ian that the thing that this whole business about showing a tree without its labels, right? Vertex labels arrow none, basically.
Yes.
Is that already here, or what's happening with that?
I haven't started writing the code for it.
Okay, I consider that a very important thing, and I want to make sure it's in 13.1.
It will be.
Okay.
Maybe a more general thing, though, which would be nice for graph, by the way, too, would be something kind of like a vertex label function, a bit like maybe vertex shape function or something, although I haven't really used that option much, because I don't know. I imagine there are cases like this where for the payload of the tree, you'd actually like to have an association with several things in it, but where, you know, you don't really want to do that because it'll make the tree look ugly.
Yes, that's a reasonable point.
I think two things we want the function versions, but we also want XPath style specifications. And either of those solve the problem that you have often of like every A, I want it to be this color, but having a function is overkill for that. You'd really want to just have a simple syntax for saying every A should be this color.
Sure, but we have that in graphs. You know how that works, right? You can just specify for vertex style, you can just specify a pattern.
Right, but it's for vertex names, and vertex names are all unique. And that's not the problem that you're trying to solve for tree, where you have data that can be duplicated in multiple places, and you're trying to specify the style based on that. I don't think there's an analog of that in graph.
No, there isn't. But why not use similarly a pattern type thing? Or maybe that's what you're proposing to do.
Well, I think that the issue is, well, I don't know. I think it would be good to have to have a function, like a bit of like a vertex shape function, but you give it both. You could give it the
I think we'll have function versions of every option. There's a like tree element shape. There'll be a tree element.
I think what Christopher is going to say is that you should be able to give it the location on the tree.
Exactly. Yeah. I mean, that's like the #2 or something. Yeah.
Yes. Is that right, Ian? Is that what you have in mind? Which is similar to vertex.
I have in mind something related to like our MetaMap, where you can specify what you want to have put into the function.
Okay. Well, so, okay, I'm still, what's a use case that you can see for file system tree, other than admiring the tree?
I've only ever used the tree command on the terminal just for admiring the tree personally, so I don't know.
Okay. Well, that's already useful. I mean, go ahead.
I was thinking that something that I would want to do is to compare two subdirectories, two trees.
Yes. Well, what tree comparison functions do we have right now?
We would need something like map thread, I think, probably.
Well, all we need something analogous to sequence analysis. You know, the oh gosh, what is that called? The
tree isomorphism.
Alignment, like sequence alignment.
Yes, tree alignment.
Are there real tree alignment algorithms though? And I guess the pattern matcher is kind of like a tree alignment.
It was very related
algorithm.
to like unification of patterns.
Yeah. Well, but I mean, no, but I think in fact our pattern matcher, which matches trees, is there a way of matching an expression against? No, you have to turn it back into an expression probably to match it, as opposed to never mind.
Well, you might be able to take a pattern and then use the tree object. You know, you use sort of make a pattern for expression trees. You know what I mean? But yeah.
Couldn't you do it as a sequence alignment type problem where you flatten the tree using one of the standard like infix forms or, you know, Polish notation or whatever?
Yes, probably. I mean, and then do sequence alignment on it. But
yes, that's what I mean.
Right. I think it's an interesting class of functions which could be prototyped in WFR to actually look at essentially tree diffs. Okay. But okay, maybe we should go back to MetaMap since you've referred to that. Okay. Is this a proposal somewhere here?
So, well, I have a proposal only for trees. If you want to open that page, tree meta applied.
The ref
I haven't thought about how this relates more broadly.
It's an exotic name.
And there's fake examples on here.
Okay, so this is a thing within TreeMap that lets you get information about. Okay, so this would normally be a function there, but this could be an operator form of this that says tree matter applied a position, open bracket f, close bracket. Is that correct?
I
Do you
I
understand
think
what I'm
that
asking?
with, I think that if we have this, whatever we call it, wrapper around the function, it can't just work by applying that function to things. It has to be like understood by the surrounding function as a wrapper.
No, I understand. I mean,
So I
Right,
mean,
yes, I
either
understand-
I
I
guess I'm saying
understand that.
either way works because TreeMap is just going to have to check to see if there's a tree
Yeah.
meta applied
Okay,
there.
fine.
Yeah, there's no syntactic reason why we couldn't have it as a thing wrapping the whole expression as opposed to.
Yeah, an operator form for the f. As opposed, right, okay. Okay, so now what you're saying is what to actually feed in. I mean, this could be in TreeMap, couldn't it? This information about what to feed in.
So we started doing this with TreeMap, attaching it to the level spec. So you see, you have level spec arrow subtree, level spec arrow original subtree.
Okay, but you're saying this
But
is
this is a
actually
thing that lets you, give an additional argument or give a sequence of arguments that you specify.
wait a minute, additional argument to this is saying instead of putting it in the level spec, you are telling it to what you want that function to apply. By default, it's just going to apply to probably what you're calling data.
Yeah.
And in principle, I could give a list of things there and it would apply to that whole, it would
Exactly.
apply as the #1, #2 to that sequence.
I think I have an example further down.
What was the reason again? Why, or was there a reason why it couldn't just, if you write hash position hash whatever inside your function, it can't just look at the function you gave it, look at what keys you used, and then you don't need this wrapper at all. Oh, I guess there was the issue of when the data, if there is sort of a generic like #1 case, if that #1 case, it could be an association.
What could be an association?
Well, I'm just remembering one of the ideas we had for this to avoid having the wrapper was to have it so that, say if you have map indexed, you can either use #1, #2, or if you just ask for hash position, then
Yeah, I get it.
But the issue is that if you're doing map indexed, #1 might be an association, in which case hash position is a meaningful thing.
Yes, but there are even worse issues, right? Because there's also the question of, if you can't put a hash there because you have to have an explicitly named function variable because of, other code outside because of a hash collision, so to speak. A different meaning of hash collision, but you understand what I mean. But you've got two nested functions and they're both using hash. You can't disambiguate that.
Yeah,
can you?
sure. Yeah, that's true.
The
I'm just a little bit, well, yeah. I mean, if nothing else, I think that the name of this thing has to be better and shorter. But yeah.
Then tree meta applied for sure.
Right. I mean, I'm just, yeah, I'm just worried that it's going to be kind of verbose.
My gut tells me if the arguments were given in an association and you used like slot position, that would make things more verbose. And
No.
You have to add boilerplate to extract
Right.
values if you want to do pattern matching.
Right. I think that this general approach, which might just be a general meta applied function, or with meta or something. No, it's meta applied is really the right thing.
Are we really going? I thought meta was kind of a placeholder name. Is meta the actual name of this thing?
But it's got metadata, so it's not completely crazy.
Oh, that's why. Okay, I didn't even realize that's why it was called that. I thought it was just called that because meta is sort of a vaguely amorphous term that was being used as a placeholder.
Well, it might have been, but we realized that it actually is including metadata.
This is actually quite close to curry applied, in the sense of, I mean, it's just using names rather than numbers to talk about arguments.
Right. Well, those are both then, I mean, curry applied and meta applied are both fairly exotic sounding things.
Yeah, I feel like if you're reading a piece of code and you see map index, that's understandable. If you're reading a piece of code and you see meta applied, that's a little harder to justify.
Well, if we can come up with a better name, but I think that the basic idea is, I mean, those strings, by the way, I don't see how we can avoid having those strings. So it's going to say, I mean, in the case of tree meta applied there, it's only being fed the position, right?
Yep.
Maybe there could be a one argument form of meta applied that does this thing where you know it looks and, but basically it just gives an association.
Yes.
Right, but then if you have the nested hash case, then you can then you can use this other syntax.
Oh, well, at the fake output, it looks like it's being also being fed to data, which is counterintuitive to me. No,
that's wrong. That cannot be the case. It cannot both have data and position, because you don't even know which order it's in and so on. Am I making sense? This has to be either, Ian, you with us, right?
I had to restart.
Okay.
Can you hear me?
Yes, we can now. Okay.
I'm actually not sure about that. So, I mean, this is modeled on map index or the position applied that we were discussing, which is adding arguments, not removing.
Okay, but it's super weird that if you have a list, position, subtree, whatever, that it is the hash blah +1 that corresponds to each of those.
I mean, the question is, when you write this, are you basically 99% of the time going to write meta applied and then you're going to write data, comma, blah, blah, blah?
My idea was that if you just say one thing, then it's applied as an additional argument. But if you give it a list, then those are the arguments that you give in order, so that you have the freedom to overwrite it. So it's not just additional, but maybe I don't want the data.
But so list of quotes position would give you a different thing from just quotes.
List of position would give only the position as the only argument.
Right. Okay.
That's not completely crazy. Yeah.
Yeah.
Okay. So let's see. So what are the possible? There's a lot here. Huh. That's a lot of interesting stuff.
And maybe ancestors could be added to this.
Yeah, like ancestor list or something.
So how would this relate to map? Couldn't map have many of this very exact, because I mean, you know, a tree is just like an expression tree. Couldn't map have many of the same meta options?
Yeah, I think map would have obviously position, index, you'd have expression or sub-expression level. So there may be some that are specific to trees, but yeah, I like the idea of having a single meta function or decorator headdress that handles this rather than having a tree permutation, an association permutation, etc.
Right. I mean, and then it might support slightly different named things depending on where it appears.
Right. If you're in an association, you may need keys and values.
All right. So this is this concept of meta applied. It's a little bit of a weird name, but it is a slightly I mean, the alternative, by the way, somebody has a bunch of background noise, but you know, it's like a with meta, but that isn't quite the right thing either. It's an applied type thing, just like curry applied, I believe. Is
Applied
it,
is a
is
bit
it?
long though, is the only unfortunate thing.
Well, it will autocomplete quickly. I don't think we have a lot of other metas.
Well, it's more about I'm thinking more about readability. I mean, if you have a long thing there, it does make it harder to read.
Yes. Well, we could always have a formatting form for it. I mean, we always could have a meta applied is some kind of, I mean, like for example, here's a weird example of a possibility that we could have something where we have, I can't really draw it, but where you have when you have this, we could have formatting of meta applied that includes that writes on top of the arrow position or something like that. Is that completely bonkers?
I think that's relatively bonkers.
In other words, that it would say you've got a function.
Well, I mean, right, this is assuming you have a pure function, first of all, right? I mean, you could just give it an f that knows what to do with the various.
I mean, I could imagine an infix form of this. I could imagine something, although that might make code look even more obscure, but it might be something where you...
And also, I mean, we just added support for basically typesetting that the \fn or the escape fn arrow. I mean, now you can write that, in outside of Mathematica. I mean, you can write it in a text editor. So I think it's sort of a bit backwards to then add another sort of thing on top of that you won't be able to write in a text editor, and you have very little hope of doing so.
Yeah. Okay. Well, okay.
I personally wouldn't use the function symbol unless it could be used in plain text.
Right.
Well, okay. In terms of the name, whether there's a meta-fied. I mean, if we think this is going to be really common, we could just call it some kind of meta thing. I mean, I don't know what. No, that's really weird.
I still think the term meta is a little bit. I mean, it just means so many. It means so many different things, and
Well, what else would you call it?
including companies that were until recently called Facebook and stuff like that. So it's sort of strange.
Metaverse is a new type of poetry.
Okay. Okay. So there's a naming question, although I feel like it is, with metadata, basically. What else could this be? What else could you call this?
Can I kind of argue that the tree version should be separate from the other version?
Yeah.
With trees, you have this additional freedom between the data at a position and the subtree at the position. And that gives rise to a lot of the specific things, but also tree meta applied has this third argument where, it's not just what arguments are given to the function, but what thing gets updated. And in trees right now, we're only ever updating the data, but it means we can't update the shape of the tree with a tree map. And this would allow a tree map to really, do any transformation to a tree.
So wait a minute. This
gets a little scary, though.
I don't necessarily want to we don't have to solve this for trees, but at that point, it's not just applying to metadata. It's some kind of how is this function getting applied, input and output.
But that's saying how it re-glues the result back into the tree. Is that correct?
Yeah.
That's a completely orthogonal issue for what the function got fed, in my view.
I mean, would it be possible to have that as an argument to TreeMap or whatever this gets eaten by? If you know what I mean? The third argument would be outside of the meta applied.
That makes sense.
Yeah, I don't believe that should be in the meta applied.
So another question, just a more basic question: is the theory of meta applied or whatever that the keys will be the same for every function that can eat it, or no, they'll be different?
I think where they overlap, they should be the same, but sometimes there'll be different kinds of things, like the payload versus whatever else is different.
Yeah, okay, fine. But so I guess the point being that it's not a problem, right? I mean, the other issue here was just that it's going to have tree specific keys, but that's fine because
I think that's fine.
Specific keys.
Yeah, because I think there's going to be, I mean, what are other places here? I mean, things like parallel map could have a meta applied that contains things like processor name and so on.
That doesn't seem as useful because there's $process ID and stuff
Well,
like that.
fair enough, fair enough.
But yeah.
Okay.
Well,
I actually, what would be useful is things to know, like how big a batch this thing was part of, that kind of stuff. Things
Sure.
known to map that are not known to the called process.
yes.
And
Or even things like progress.
What about contextual applied?
it's long, but it's not. Well, the only problem is that context. Well,
Yeah,
contextualized of F or something.
Mhm.
Well, there's also environment, but that's all these words have such ridiculous additional baggage.
Yeah, I was thinking markup, but that's also the wrong direction.
It's basically what arguments you are supplying. It's like the handler functions. It's I don't know. This requires more thought. It's some kind of contextualized. Well, there's got to be a better term than environmentalized, so to speak, is really what we're looking for.
And by the way, there is also the option of just calling it metadata, but that might be.
I don't think. I think that's weird because it's a function. You know, it's a whole function story and so on.
Well, if we are going to remove the applied, perhaps something similar like extended.
Yeah, possibly. Of course, there is a possibility of just the word applied by itself.
We also have apply and what
I
map
know.
apply
Yeah.
or map applied.
Element applied,
That seems obscure.
property applied.
Where am I putting this? LD. Okay, so what are our possible names here? We've got meta applied. We've got contextualized. Well, it's often going to look like this. I mean, that's pretty obscure, I have to admit. Meta applied position of F is pretty obscure.
Oh, is the syntax that, or is it position the first argument, or is position the last argument?
Well, I think it's this, or it's meta applied of F comma position.
I mean, it could also be meta applied of quotes position comma F, which actually has a bit of an analogy to the syntax for function, like as in pure functions, like those are the arguments.
Yep.
Yeah, that's a good point.
And the list versus not list.
Well, so what about the possibility of decorating function in some way? Is that obviously completely crazy? Like, for example, let's
a fourth argument.
No, I was thinking of something like this, but this is perhaps crazy.
Or maybe even a threaded version of that.
Yes.
I mean, it's the only, like, it's not obviously crazy. I mean, it's a bit long, but then the issue is that if you just have an F, it doesn't work. And if you want to write with hash, it doesn't work either.
Right.
I mean, unless we did something, we could do something for the hash case of if you just don't specify the X and Y, then
No,
just
it's
as function of one
ambiguous.
argument. Well, it's not ambiguous because you can't
That's
have
a string.
strings. You can't have strings there, but it's weird.
Right.
And it will
So that
lead to
would
the
be-
weirdest bugs in the world.
Will be something like this, comma, #1 plus #2. That's crazy. That's wrong. Wait a minute. What do you even do with function? What do you do with hashes inside function? Does it work?
They turn green when it's one argument. I mean, here it just yeah.
Oh. Right. Okay, but then
That looks a little crazy.
it does look a little crazy. But this is conceptually what's happening. It's bringing in additional. Okay, so what we've got.
Well, really, it's if anything, it's. I mean, I hate to say it, it's a little bit like typed, because it's like typed. It's saying, okay, this is the name of the variable, and this is what I expect to be passed into this argument.
Yes.
Right? I mean, typed is telling you what the type is going to be. This is a bit higher level.
Well, typed is characterizing what X could be, as opposed to where X gets itself value from.
Well, no, but this is
Like
the same
signature
thing.
applied.
That sounds like digital signatures.
Like the type signature. Oh.
But the thing is, it's not a type, right? I mean, it's in the same way, though, that typed is basically telling you, I want you to give me an integer into this argument. This is also the function telling you what it wants you to feed into its arguments.
Yes, that's true.
But I mean, I mentioned this, but I also think that I can't imagine there's a reasonable syntax that can come from this analogy.
Right, and I mean, I would think that if we go to the trouble of extending the syntax of function, we'd want it something more general, like supporting patterns or something, as opposed to this very specific case.
What about if you want something short? What about fed?
Thinking
Fed, like as in, wait,
Like
fed
in
as in
feedstock.
eaten,
Yes.
not like the
Or
Federal
feed.
Reserve.
Right. Not like the Federal Reserve. The
Fed as in your pets.
feed. I mean, it is what people say.
feed in position.
Yeah.
What about
Feed does
or
also
is
mean
that
like
too general?
About like give.
include.
Supply.
So I think to list the complaints, right? So I think feed sounds like RSS feed, which might be fine. Include sounds like needs, or like there are too many, in C. Yeah.
With is already taken.
Yep.
What about using?
Using also sounds like include. Too many languages use using as include, or as it's like needs.
Yeah, except that you'll be able to see that it's saying using position. That's not crazy.
Right. I'm thinking more of a writing perspective than a reading perspective, in the sense that someone is going to write using instead of writing needs and just be confused. But yeah,
But takes.
it's not too bad. Wait, what is using already? It's black.
Apparently used by roots. It's an option.
What?
It's not documented. If you look at the
That's
usage,
ancient. It's for nested roots, and it's absolutely ancient. It could be changed, I'm pretty sure, because it's strictly internal.
Yeah, it's not.
That's one of those. I like the mentality toward using it. I mean, I love these version 2 symbols that are taken, where it's like,
version
this
1.
common English word is taken.
Version
by
1. Yeah,
Version
it's
1 and
version-
never
roots.
documented.
No, it really shouldn't be. And it probably could even be stringified or put in an internal context as some other name.
Okay. Using is interesting, in my view. I mean, so what it would look like is map using position of, or using index, for example, of that. would be map indexed, basically.
And can you
I
try
would think
writing it with
index would
commas?
be just the number, and position would be like map indexed.
Exactly. So this is in fact that's the thing you often want with map index.
So I'm saying that would not give you map indexed.
You're correct. It will be this one which gives you map indexed.
But index
It's
is something
unfortunate
people
that
want.
well, it's unfortunate that we can't be, it would be nice if it was called, map position or something like that, because in that way we could have positions or like the extract style, and indices are like the numbers, but we've been inconsistent.
We can add a possible issues. Map index should have been called map positions.
Well, we could also have a function called map positions going forward.
Yeah,
the problem is we
feels
can't
wrong.
change map index, so that doesn't really make, doesn't really help anything.
But sorry, can you write these using examples using a comma instead of the bracket, the like very curried,
Well, which order do you want to put it in?
Try both.
Yeah. Okay. All right. So then, okay. So you're saying
we have something similar with curry applied, in which is f comma n.
Yes, which is just like this.
Exactly. And when we use carrying, we typically carry the second argument, not the first.
So the argument for having the quotes be at the beginning is for, because realistically f is going to be long. And so if you have the thing that says position at the beginning, honestly, I think it's a bit more readable because it's a bit closer to writing map indexed, where you get to see what's being, fed to the function at the beginning.
Right. On the other hand, the other argument would be, if you want to do that, use the curried form.
Mm-hmm.
Yeah. I just think the curried form is a little bit obscure looking. Like it's easy to, especially because this is such a basic, if the idea is that basically this is what you should use instead of map indexed in the future, I don't know, like, explaining to a beginning Mathematica programmer, like, oh, this is the syntax, it's so much more complicated than map indexed right now.
Yeah, that's pretty obscure. But this would be, okay, so you're saying using index f.
Another thing to note would be if f is a function, is written by like saying function open bracket blah blah blah, then the things like position and so on will be right next to where the argument names are specified.
Yeah, but I still think if you want it first, use the curried form. If you want it second, I mean, using index.
I mean, the thing is, I argue that the curried forms are for when you have a function that you'd like to, for example, map. You'd like to map over things, you'd like to select over things, etc. I think curried forms are not really for, we want a version of this function where its arguments go the other way around. Because I can see no scenario where you actually using of quotes position in like a functional way, like feeding it to map or something like that.
Take, for example, a case in which you are going to be using this with lots of functions, and you want to define a symbol int equals using index, and then you just use int f, int g, int whatever.
Where int means it's in, the indexed version.
Yes, so it would just be
that.
Index.
But you'd hope that whatever syntax we have is short enough that you don't need to make a shorthand like that, right?
No, I'm just trying to point out a case in which you would use a carried form. This was the same discussion we had with carry, and it was one of the reasons why we have separate carry applied and operator applied, just to allow this in carry applied.
To allow curry applied of 1, curry applied of 2 of f.
Mm-hmm.
Ag. F X Y.
Yep. Right, but I feel like in this case, isn't it? Well, But is there ever a situation where you're going to, for example, be mapping your curry applied over something, or you're going to be selecting something by curry applied, or if you get what I mean?
Yes, I think so. Curry applied. Well,
no, without the F, just curry applied of 2.
No, that's pretty obscure.
And the other thing is that I would argue that curry applied, I think the tolerance for having weird curried bracket wizardry stuff is the tolerance for that's much higher with curry applied, because this function's whole purpose is to enable crazy bracket wizardry stuff.
Right.
Okay,
but I
mean, I'm just thinking people struggle, beginning mathematical programmers struggle enough with like where does the close bracket go, let alone if you have some triple curried thing every time you want to use map indexed.
I feel like using of index comma F might be confusing because the index is in the first argument, but it's getting passed as the second argument to F.
That's a very crazy, weird thing, because obviously
if you do using of F comma index, like nothing is changing orders.
Well, that's a weird argument, but I have to say I tend to think, look, we could have an alternative. We could have alternatives for this that involve being able to put this stuff into level specs and so on. We could have multiple syntaxes, just like /@ is a alternative syntax for map.
Well, okay, but I think that the thing is, I think it's, I think it's fine, if the position is in either the first or the second argument of using. The thing I oppose is just the idea of like we're gonna have 2 syntaxes where it's not really clear which is the preferred one, and both of them work. And we're just kind of leaving it up to users to say like, which one is more readable.
Wait a second. Of which and which? Of currying and non-currying, or what?
Yeah. Like I think supporting both of those is a little bit pointless. Because the curried one, the only purpose that the curried one serves is to let you put the arguments in the reverse order, right? And that's the only reason we've thought of for why you want to use it.
Okay, but you could argue that @ and / are also, why do we need those? Well, it's because
they're shorter.
Well,
but they always make your code look better. You should always use those, and you should only use the explicit forms if you need to give a level spec or something like that. The point is with this, there is no, what is the decision tree for how you decide which syntax you're going to use? And if the answer is just like, oh, it's based on your personal preference on which one is more readable, then this is kind of like, well, we should just tell them what's the more readable one.
Okay. Fair point, but I'm not convinced here. But let's. I do like your argument about this being long and it being very obscure. What you are looking for if this goes second. On the other hand, the argument that curry applied has that second. I don't know. I mean, I can see the argument that it reads nicely if you say using index F.
I mean, I think, by the way, using F index is also pretty much fine. I just think having both doesn't work.
Both what?
Both directions by having the curried hack.
Well, we
like either the string goes first or second, and saying it goes second, but there's a curried form so that you can put it first. And we're not going to tell you how you decide which one to use. I think that's what I don't like.
Well, but so, all right.
Note the vast majority of our carried operators carry the second argument, so that they do this flip.
Okay, but I'll give you an argument for this way around. If you're writing this code, there's a very high probability you want to use the index before you start writing the F. So it's natural to put that first.
Mm-hmm.
Okay.
Right. I also think it's just easier. I mean, I guess I'm repeating Christopher here, but I just think it's easier to read, right? You see what you're going to be using, and then you can interpret any explicit hashes in the argument.
Oh, I see what you're saying. That's a good point, that the hashes are otherwise uninterpretable until you get to the end. Okay, well, so provisionally, this looks like a reasonable syntax. Dan on our live stream mentions with metadata, which yes, that is a. I mean, I think using may be better, but I think and using is much better than meta. Meta is just obscure. Says the person who's about to put out this tome about meta mathematics, which is obscure from the beginning. Okay, so what do we want to discuss about this? So we have shot down the idea that we need a separate tree meta applied. Is that a true statement?
So, well, different functions that support using, like in their notes section, they'll have to say what things you can use inside the using.
Exactly, just like they do for many other kinds of options, like from I don't know, color functions to many other things. But you have discussed a different thing, which is the regluing of trees.
Yeah, I'll explore if the regluing can just be specified in the function.
Okay.
Instead of having it in this.
Okay.
Maybe.
And let's think about where using could also be used, so to speak. I mean, this seems like a good general construct. It's like one could use it in, for example, how would it work in things like nearest? It will be an alternative to the syntax that we have right now.
Well, nearest, the syntax, if you're thinking of the arrow syntax, that determines what's returned, not what's passed into any function.
Oh, I see. But what this could be used for is these things where we have, well, actually this color function stuff and those kinds of things could use this in principle. Right, where you have think about that, where you're giving 1, 2, 3, 4, or alternatively something, all these various things where they have a comparison function, where we have these other kinds of functions, particularly ones where we have multiple arguments. You know, we could name those arguments and we could allow people, okay, so the question is, what's the relationship between, okay, so look, there might also be the possibility of something like using all, and then this F would become an association, you know, would be fed an association. Etc.
And all would again depend on the function, right?
It would depend on the function, but then the whole point is that then in the F there, you'll be able to say using all, and then
this was also the proposed thing about having a single argument version of it. So using of F would be, I mean, maybe
I see. That's interesting.
Using the name using is a little bit weird with that, but using of F would be effectively that, and maybe it could even be optimized so that it looks.
Yeah, so it tries to look at the function.
Yeah.
That's interesting. Yeah, so if it happens
again, the
to be
name using is
no hopeless for that case.
Yeah.
But I do like the possibility of having a one argument wrapper, and that would shoot down my currying, because I think this is significantly more useful than the curried case. I mean, this is a case where the whole metadata thing, what could this be?
Honestly, I have to imagine that the single, I mean, if the single argument form can be done, you know, that's the only thing you'll ever use. I mean, it's like the multi-argument one will only ever be useful basically for nested pure functions or something.
Or say you just want to use F in your code and then define F using down values and not have it be something that takes an association.
Sure. But I mean, yeah. But I mean, most of the time, if you're writing a function yourself and you're mapping it or something like that, and you get to design how the arguments look, you're just writing a pure function. So
Yeah, I mean, I think this is not an unreasonable thing to want to do. Okay, so one question would be, could we define a function which essentially expects to do this lexically? I mean,
I mean,
this
the
is,
zeroth thing is just, it could just pass in an association. That would work. I mean, I don't know if there's performance problems with it. I mean, that was one of the things that's one of the things
you have to form the.
I think the point is that you want to analyze and know which keys you need. Like, if you don't want the negative level, then you don't want to have to do a depth first traversal just to get it.
Yeah, it's a good example.
Right, and also, but even more generally, something like, I mean, yes, for the tree example, that's a good one, but even more for just like map indexed. If you run map indexed and it has to construct an association, even if it's just an association of the index and the value for every iteration, that's going to have a huge performance impact.
Right. So you don't want to be able to have to do it. But the question is, can we give a name where it is a reasonable thing to lexically scan the code? And clearly with is known to be a lexical scanning function.
Well, but I mean, the point is that I don't think you don't need to know that it's lexically scanning it, because it'll be the behavior will be absolutely identical, right?
Why? I don't understand. If the thing is going to be passing.
Oh, I guess there could be certain.
No, because if you just have f of hash, what?
Yeah, if you have f of hash, then I mean, but yeah, but then it can see that you have a hash and not a hash position, right?
Oh, I see what you're saying.
And of course, it's not hold first, so it's not like, so whatever the function is going to be, if it is a pure function.
Okay.
Right. If you're constructing a function with if there's a piece of code that returns the pure function, it'll have evaluated by the time you're doing this.
Okay. What about colliding hashes?
Like if there's a nested, if inside of the using, there's another using in some nested way.
Is that what? Well, we have to think through what that case is. I think it's a much simpler case, right? I mean, if you have something hash plus. No, your point is that within the using, you have, yeah, right. I mean, this is the case. But that case is kind of crazy. I mean, within the using, we're
right.
trying to access the external hash.
Right. You can also have cases where I bet you can have cases where it's pretty hard to tell, is this hash position from this using, or is it from this using, and what key was included in this using, and stuff like that. But honestly, I think, given that this is just sort of behind the scenes invisible optimization, worst case, it computes a little bit too much, right? And it was still
no, I don't understand, but why doesn't it refer to the wrong hash? In the case,
this is just a problem of nested pure functions. I mean,
right. I mean, this one will do nothing, right? I mean, if you use this map, the inner pound, the outer pound, the one to the left of the plus, will be fed the values of the thing, and the using will just sit there inert because those are not pure variables of the outer ampersand.
No, I understand. But okay, so your claim is you will never need a named version. You can always use.
No, I think there will be a named version in some cases, but it'll be, and like Ian said, I mean, if you want to pass it f, defined with down values, then you need to have a named case. But
okay, so what about the possibility of messing with the function in the named case? What about if most of the elided form is done with a wrapper and then well.
Right, but see, I don't think that pound thing can work. The using of just pound, right? You'd have to use pound position and pound data and whatever, right? Because pound would be referring to like the whole association, right?
Yes.
Yeah,
would.
exactly. Yeah.
Yes. Okay, so I think we need a name for this case. This is a nice case. I agree. I think that this is
I think there's two cases that you might want: all or automatic. Like all is the association of everything that could be computed, and automatic is lexically scan this pure function and only compute the things that show up in the slots.
right. Or you could explicitly say what to compute. That's what you're saying. Is that's
like if you use slot position, then it has to compute it.
No, I understand. But if okay, but the question, okay, so then what do we need here? We need a wrapper. See, I'm worried that people will forget the wrapper unless we name it very carefully. So they just think they can type slot position in a map, and a function to be used in the map. Well, I mean, we can clearly have some code assistance things. I mean, clearly what we could do there, if it can tell that it is making a function that is only to be used in the map, that is, it has an ampersand closing it off inside the map, it could turn it red in the case where you don't have a using around it. Could it not?
What if you're mapping on something that has that key in it? Then that's a false negative.
Yeah, okay.
Yeah.
That's not going to work. Right, so we have to have some way. Okay, all right. We should wrap up in a moment here, but well, I like the general concept of this. I think it requires more thought. Okay, and with respect to our file system tree, I think we need some more use cases. I mean, for example, do you expect to do TreeMap of file system tree?
I don't know.
Well, but I mean, that's an example of something.
File system map is essentially would be that, but only on the leaves. Whereas doing a tree map would allow you to map on inner nodes.
I certainly would like to do that with sizes. So knowing the distribution of sizes and how they are splitting,
yes,
would be very useful.
Well, so then that's a good case where you might want to display. Okay, where you say the nodes might be a name and a size or something, but where you might want to display, I don't know what you would do. I mean, and also eliding the names. Do we have an easy way? Because the names might get really long. Do we have an easy way to specify that? And this is part of the Vertex display function thing, to specify that you want to only show the first 10 characters of the name or some such other thing.
No.
Right, so we should have a mechanism for that, because that's going to come up quite a lot. Am I making sense? Do you understand? Ian, do you understand?
I kind of think that the more pressing issue is that the layout currently doesn't take any kind of information about the size into account. So you can end up with trees with lots of white space or with weird collisions.
No. We're talking about actual file sizes. What are you talking about? Sorry, we're talking about.
Are you talking about the way you're talking about visualization of the file system tree?
Yes, and we're talking about, and what Jose was saying is that he would like to know the size of each file going down the hierarchy of files, directories and files and so on. Okay. And then what I was saying was, okay, but if you display that and you have a very long file name, it's going to mess up the actual display of the tree. So what I was then saying was the name of the file, if it's 50 characters long, should be 8 characters and then ... That's all I was saying. And so then I was saying, what is our mechanism for eliding, doing a short, for example, on every, that was the thing you were talking about, Vertex. It'd
be like a Vertex label function goes to short.
Yeah, for example. Yes, exactly. That's exactly what we're talking about there. And having an easy way to do that, because vertex label function goes to none, which is a bit like vertex labels. Actually, none is the wrong thing there. So it's like vertex labels goes to none is what I keep on wanting for these trees. Just show me the structure of the tree. Making sense?
Mm-hmm.
I mean, that's the case, which for me is the number one use case for trees. Right? I don't want to see the content. I just want to know the structure of the tree. Now, by the way, what's the state of doing XML trees? Actually, there are two questions. Have we thought about how text structure is going to work with trees?
You will be able to do expression tree of a text element and get a tree. If you open the prototype build, you should be able to do expression tree of XML.
But I think he's talking about something else.
I'm talking about text structure here, the text structure function.
Yeah, that will just be another thing that's supported by expression tree.
What? Wait a minute. No. I'm talking about if I want to get out of this, what is it called? Isn't it called constituent trees?
I mean, isn't the full form of that some nice thing anyway?
Yeah.
And what if you just say
nested tree
expression tree on
elements.
it right now?
Well, it'll give you the underlying expression, but it won't give you this tree.
Right, but that's the point. I want to be able to get this tree out of text structure.
Yeah,
As a tree.
you will literally just do expression tree of the text structure and you'll get this tree.
Wait, but then that means expression tree doesn't always just give you the tree of the full form. It might do intelligent
Right,
things.
which we decided last time we discussed expression tree, that expression tree should be smart and figure out what kind of tree you gave it.
Okay, but I'm not sure you want to have to do expression tree here. This thing, text structure of blah, comma, tree, should just give this frigging tree as a tree without you having to wrap the text structure. You know what I'm saying? A different property of text structure should just give the tree.
Yeah,
That makes
that's
sense.
clear.
Yeah.
Okay, let me see one thing.
But wait, by the way, I mean, is that, sorry, about the expression tree thing, I mean, don't we have like a tree expression? I mean, are these things going to round trip all the time?
Certainly, if you specify the structure, then it will round trip.
Well, what do you mean if you specify the structure? I mean, like, I'm just
Like
wondering.
if you say comma text structure, then it'll know convert this tree into a text element. But there might be an issue with like automatically detecting from a tree for tree expression.
Right. I mean, but if I have some big, expression and in the middle of it is a text structure, is it going to?
No.
It's going to just unpack it as an expression.
Yes. The structure is just based off of the outer like top level expression.
Okay, I don't know. I'm slightly suspicious of it, but I mean, it does seem like there probably are many cases where it's like we have some object and we want to turn it into a tree.
So the current behavior always uses a specific structure, and you have to specify a different structure if that's what you want.
Yeah, I don't think it's right, but we'll come back to that at a different time because I have to go in a moment here. So are you going to show me this? What do we do here?
Yeah, I say expression tree of that, comma, XML.
So the point is that we're losing all the XML element stuff in there. Is that correct?
Mm-hmm.
But if I say here, tree expression.
You would say tree expression of that, comma, XML.
Okay, that's quite nice. Is it right? Yes, it is right. Can I just look at one realistic? These are really bad examples.
Do import example data / paintings.xml.
paintings
Yes.
like this. It doesn't default to XML if it sees an XML element there.
No, not yet.
Okay, this is not useful again here. I mean, we got to find a way. Look, this tree needs to have more vertical height. Okay, what am I supposed to do here? Other than just make my window wider.
I think what we really want is an outline view,
Yes, we do.
not a graph view.
Yes, we do. Okay, well, that's nice.
By the way, what about other, I mean, I can imagine we could have other tree layouts, like some sort of radial thing.
Yeah,
and stuff
there's a
like
tree layout option.
And what
Oh,
about
already,
putting
okay.
it to the left?
Do tree layout goes to left.
Much more useful. What the hell happened there? What's that?
So it was empty.
A bug.
No, it's not a bug. The XML object document has a preamble. I don't know the official terminology. It has a preamble and then the body and then an afterword. And the afterword was the empty list.
I see. Okay, that's not bad. Cool. All right, I should run off here. Okay, well, this is good. This is good. I think we've got some definite things to do next. Yes?
Mhm.
Yep.
Okay, sounds good.